All right, in lesson 8A and 8C, we're going to talk about risk and risk assessment. And we're really mathematically talking about risk. What's the absolute increase in the risk, or maybe what's the relative increase in the risk? Readers of USA Today may remember this headline. Put down the bacon. Report emphasizes cancer fat links. In this article, USA Today quotes the American Institute for Cancer Research and the World Cancer Research Fund as follows. Every 1.7 ounces, I'm going to kind of underline the things that are mathematical, that's a quantitative number. Every 1.7 ounces of processed meat consumed a day increases the risk of colorectal cancer by 21%. So it increases the risk of colorectal cancer. We're going to look at our objectives. We can look at risk in terms of absolute and relative terms. We have to pay attention to contextual information. What are the words telling us exactly? And the fact that different ways of expressing this data serve different purposes. It says locate the data given about colorectal cancer in the lesson. Introduction. What risk measure does the quoted article provide? Explain the risk measure. What does it mean? Well, it's a little unclear, but basically they're saying every 1.7 ounces of processed meat. I may have to go back. Let's go back and see. Consumed per day. Gives us an increased colorectal cancer risk of 21%. Okay, first of all, it's a little bit fuzzy here. This would mean if you ate 1.7 ounces of processed meat every single day, doing it once and then not doing it again is not going to increase your cancer risk 21%. But if every day you eat 1.7 ounces more, you will add that much risk to your cancer. But 21% of what? It increases your current risk by 21%. So unless we know what our current risk is, this really doesn't tell us very much about our new risk. Here's the current risk. The risk of developing colorectal cancer in a lifetime for men is 1 in 20. For females, it's 1 in 22. So what percent of American men develop colorectal cancer during their lifetime? If we want it as a percent, 1 out of 20. If you divide that, that's 0.05 or 5%. Remember, there's 20 nickels in a dollar. So a nickel is 1/20th of a dollar. So a nickel represents that 5%. It says the American Cancer Society reported the data about men as a fraction with a number of 1. In question 2, you reported the data as a percent. There's many other ways to report risk. For example, convert the percent to a fraction with a denominator of 100. So 5% is 5 out of 100. We were originally given 1 out of 20. This fraction is a natural frequency often reported as 5 men out of 100 will develop colorectal cancer in their lifetime. The ratios reported by the American Cancer Society are baseline risk figures. because they provide a basis for estimating the chance that an individual in the United States will develop colorectal cancer without knowing anything specific about the particular individual, other than their sex and that they live in the United States. In other words, they don't factor in, are they overweight? What are their lifestyle choices like? Do they have hypertension or diabetes? All of those things might impact. But if you just look at Americans as a whole and you just divide them into two broad categories, the risk for men is 1 out of 20. What is the baseline risk for an American woman expressed as a percent? Well, they told us for women it was 1 out of 22. If I divide 1 by 22, I get a decimal that looks like this, 0.045. Actually repeats, but if I move it 2 places, I can see that that's approximately 4.5%. All right, imagine that every American male begins eating an additional 1.7 ounces of bacon daily. Bacon is a processed meat. There's other processed meat, things like hot dogs and bologna. According to the USA Today article, the risk for colorectal cancer increases by 21%. The current risk for developing cancer is 5%. Multiply 21% by 5%. So what we want to do is we want to, so our current risk here, what is 21% of 5%? We write that as a decimal. It would be 1.05%. This is the increase. So what's your new risk? It says product from question 5 represents the increase in baseline risk caused by eating an additional 1.7 ounces of bacon. Add this increased risk to the original baseline risk and round to the nearest whole percent. So our original risk was 5%, but if we increase that, our increase in risk was an additional 1.05%. But if we round that to the nearest whole number, it's going to be 6%. So eating that bacon increased your risk, your lifetime risk, from 5% to 6%. You know, that's really different than the 21% we read in the headline. So express this adjusted baseline risk as a natural frequency. In other words, this turns into 6%. That's 6 out of 100 men would develop colorectal cancer. When they weren't, before they added that extra 1.7 ounces of bacon every single day, it was only 5 men. So that bacon's going to impact one more person out of a group of 100 men. Look at the information gathered in the previous question. How many additional men per 100 developed colorectal cancer in their lifetime? It resulted in 1 more man. It's not as dramatic as that 21% increase might have made you think. The USA Today article reported a 21% increase in risk. This risk measurement is a relative risk, since the 21% increase is relative to the existing 5% risk for men and 4.5% for women. In question 5, you calculated the absolute increase in risk as a percent. In question 7, you calculated the absolute increase in risk as a natural frequency. In which opinion, which of these forms gives the most useful information? So what do we have? we had the relative risk, which was that 21% increase, and that was relative to the original 5%. When we calculated the absolute increase, it was 1%. Or if you want to be real fussy, it was 1.05%. There was a 1% absolute increase. It went from 5% to 6%. And then finally, if we want to do absolute increase in terms of natural frequency, it was one more person, or man in particular, out of 100. There it went from 5 men to 6 men. Okay. So we're looking at this same risk, but we're just looking at it in different ways. Notice if I said that eating 1.7 ounces of processed meat every single day would result in one more case of colorectal cancer out of every group of 100 men, you might not have been as impressed. It sounds bigger when you say it's a 21% increase. But you remember it's 21% of what? In this case, it was 21% increase of a 5% chance. Why do you think news reports like the USA Today article report risk in relative terms? Well, the relative risk sounds bigger. It was 21%. The absolute increase was only 1%, from 5% of men to 6%. But there is a 21% increase, or 20%, when you go from 5% to 6%. All right, reducing the risk. So this is more at looking at ways of measuring risk. Says readers of USA Today may remember this headline: white fruits and vegetables may lower stroke risk. Apples and pears are white fruits. Cauliflower is a white vegetable. In the article, USA Today quotes Dutch researchers. Every 25 grams per day of white fruits and vegetables consumed led to a 9% decrease in the risk of stroke. So it would lower your stroke risk by 9%. Many drugs are designed to reduce the risk of a disease or to reduce the severity. A new drug advertises that it reduces the risk of a heart attack by 50%. Do you think this is an effective or good drug? I would say reducing the risk by 50% depends on how much risk you already have. If you're in a high-risk group, cutting your risk in half would be amazing. On the other hand, if you're relatively healthy and young and at minimal risk, half of a very small amount is only a small reduction in risk. All right, let's look at these two groups. In order to understand the benefit of this drug, you will examine heart attack risk for two different groups. Group 1 consists of individuals in Africa who are 40 years old. They do not have diabetes, but they do smoke tobacco, they have high cholesterol, and they have high blood pressure. These are all really high-risk behaviors. Group 2 consists of individuals in Africa who are 40 years old. They do not have diabetes, but they also do not smoke, have low cholesterol, and have high blood pressure. So the only big difference is they don't smoke and they have low cholesterol. Guess I should have marked this a little different here. Hang on. That's where they differ. Everything else is alike. Though this group smokes and has high cholesterol, those are two big red flags for heart disease. This group does not smoke and does not have high cholesterol. In fact, they have low cholesterol. Group 1 is at high risk of a heart attack. This group has a greater than 40% chance of having a heart attack in the next 10 years. Group 2 is at a lower risk of heart attack. Less than 10% of Group 2 will have a heart attack in the next 10 years. All right. If 500 people from Group 1 are observed for 10 years, how many individuals would you expect to suffer a heart attack within this time period? Well, it says greater than 40%, so I would expect a minimum of 40%. So if we have 40% of 500 people, you can do that as 0.40. That would be 200 people that you could expect to have a heart attack out of that high-risk group. If 500 people from Group 1 are treated with the new drug from question 1 and then observed for 10 years, how many individuals would you expect to suffer a heart attack within this time? Well, it said it reduces the risk by 50%. Well, in this case, they mean 50% of the risk, which we know was 40%. 50% is the same thing as half. Half of 40% means we now have a 20% risk. If we do 20% of 500 people, you get 100 people. Remember before it was 200. So this drug cut the number of heart attacks in half. That's a reduction of 50% risk. And in this group, it's pretty dramatic. That's 100 people out of that group of 500. So I would say for this group of people, this is a highly effective drug. Just create a bar graph using the one below as a guide that represents the information from questions 3 and 4. Use different shading for the bars representing with treatment and without treatment. So, how many heart attacks without the drug? If we do not have the drug, we expect to get 200 heart attacks. I'll tell you what, we'll make it fill it up like a whoops. Okay. So you can see they put a little, so without the drug, we think 200 people are going to get heart attacks. What does that mean? Well, that means that the number of people that don't get heart attacks would be 300. So this is, the blue is no drug. With the drug, whoa, with the drug, this falls from 200 down to 100 people. And the number of people that won't have a heart attack is going to climb to 400 people. Obviously, that's a big improvement. We would like this green bar to be all the way up to 500, that nobody in our group. But you can see we had a reduction in heart attacks and an increase in the people without heart attacks. I would say for people in this group, reducing heart attacks by 100 people out of 500 would be very good. Let's answer question 6. If 500 people from group 2 are observed for 10 years, how many individuals would you expect to suffer a heart attack within this time period? Well, if you're in group 2, it says less than 10%. So the very most heart attacks that we might expect would be 10%. So 10% of 500 people would be 50 people. If 500 people from group 2 are treated with the new drug and then observed for 10 years, how many individuals would you expect to suffer a heart attack within this time? Well, it's going to cut that 10% down. If you reduce by 50%, that's the same as saying you're cutting it in half. We only think 5% would get it. Well, 5% of 500 people would be 0.05 is only 25 people. So we did the same thing we did before. We figured out the risk without treatment was that 50 people would get heart disease. With the drug treatment, that would fall to 25 people. If we make the same graph, it's going to be much smaller. So let's do without the drug before we did blue. So without the drug, we think 50 people will have a heart attack. That means 450 won't. If we use that drug and we cut that risk in half, there'll be a slightly smaller. It's going to fall to 25%. And we will have slightly more that do not have heart attacks. This is where you get into risk benefit. In the first case, you were prescribing drug to 500 people, and in doing so, you effectively saved 100 additional lives, or prevented, maybe you didn't save lives, you prevented 100 heart attacks. In this case, you prescribed it to 500 people, but you only prevented 25 heart attacks. That may still be worthwhile, preventing 25 heart attacks, but it doesn't have the dramatic effect that it does on the other group. It doesn't prevent the same, it doesn't reduce the risk by the same absolute amount. Since if you are planning to publish this report in a health blog to advise people interested in using the drug, write a few sentences to accompany the graph. I think in this sense that you would say something along the lines. If you are at high risk of having a heart attack, that group that has 40% or higher risk, then it makes sense to have drug treatment to dramatically cut that risk in half, to take a 40% risk and knock it down to a 20% risk. If you're at low risk, you have a 10% risk or maybe even less than that, it might not make sense to treat in that second example, we were treating 500 people and it really only had a positive effect on 25 people. That means 475 people were taking a drug that did not improve their health. That's something to think about. I believe that's the end of this lesson. And so I will quit right here.